Okay, we're going to talk about family of functions, section 2.6. Different non-vertical lines have different slopes, or y-intercepts, or both. They are graphs of different linear functions. For two such lines, you can think of one as a transformation, that's a key word here in this section, transformation of the other. A transformation is taking a graph and moving it around. You can move it up, down, left, right, stretching it both ways, and so on. So there's a lot of different transformations, and we're going to talk about all of them during this section. There are a set of functions called families, family of functions, in which each function is a transformation of a special function called the parent. The parent is the original function, and the family is the one functions that are related to it. The linear functions form a family of functions. Each linear function is a transformation of y equals x. The function y equals x is the parent function. So this is a parent function, and anything that goes with it is its family of functions. So for example, if y equals x is the parent function, then y equals x plus 1 is a family of function because it moves the graph up 1 unit. One type of transformation is a translation. A translation shifts the graph of the parent function horizontally, vertically, or both without changing the shape or orientation. For a positive constant k and a parent function f of x plus or minus k is a vertical translation. So in other words, if we just add a number to the end of the equation, take our original function f of x, add a value or subtract a value, it's going to move the graph up and down. For a positive constant h, f of x plus h plus or minus h is a horizontal translation. So if it's inside the parentheses, it's going to move it left or right. If it's positive, it's going to move it to the left. If it's negative, it's move it to the right. Now what I always say is what makes it 0 is to tell you where it goes. Now how are the functions this and this related? How are the graphs related? So in other words, here let's say this is my parent function. Now we get 2x, y equals 2x. Now y equals 2x minus 3. Well, the minus 3 is going to take the whole graph and move it down 3 units. This is that parent function, and that minus 3 is on the outside, so it's going to move it down 3 units. Now it says, what is the graph of y equals 3x translated up 2 units? Well, here's our parent function. Now if we're going to translate that up 2 units, we're going to have y is equal to 3x plus 2 to move it up 2 units. Now a reflection flips the graph of the function across a line, such as the x or y axis. Each point on the graph of the reflected function is the same distance from the line of the reflection as its corresponding point on the graph of the original function. When you reflect the graph in the y-axis, the x values changes signs and the y values stay the same. When you reflect a graph in the x-axis, the x values stay the same and the y values changes. So in this is for a function f of x, the reflection in the y-axis is f of a negative x, remember that, and the reflection in the x-axis is a negative f of x. So notice here, reflection of f of x in the y-axis. Here's the y-axis. Or flipped it across. Looks the same but flipped across. Now reflection of this one across the x-axis. Now a vertical stretch multiplies all the y values of the function by the same factor greater than 1. A vertical compression reduces all the y values of the function by the same factor between 0 and 1. For a function f of x and a constant a, y equals af of x is a vertical stretch when a is greater than 0, and a vertical compression when a is less than 1 and greater, I shouldn't say greater than 0, greater than 1 when a is less than 1, greater than 0. So we're going to stretch and shrink it if we put a number out front. It says, let's start with a reflection. Let g of x be a reflection of this in the y-axis. What rule is g of x? Now, so g of x is, we're going across the x-axis, so that means it's going to be f of a negative x. Now if I put that in there, go up here and put a negative x in, I'm going to have 3 negative x plus 3, which is equal to a negative 3x plus 3. So my reflection is this one. So that's the equation of the graph. So if I was drawing this graph out, I'm not very good at drawing. First equation was 3x plus 3, so I'm going to go up to 3. And then 3x plus 3 would be a line like that. Now this one is go up to 3 and going down the other way. So they are reflected across the y-axis. Not a very good graph, but it kind of gives you the point where I'm looking at. Let h of x be the reflection of this in the x-axis. What is the function of h of x? Well, h of x then, if it's the x-axis, means it's going to be a negative f of x. And so on here, what we're going to do is we're going to go negative the equation 3x plus 3, which is equal to a negative 3x minus 3. So you notice on here, when we reflect across the y-axis, it's going to switch the negative and the negative, both of them. So now let's look at this. What transformations changes the graph of f of x to the graph of g of x? Well, so here's our f of x. Now we're going to go here. So I can think about a couple ways. I can say, okay, this is 3 times 2x squared minus 1. What is the transformation? The 3 out front is going to stretch my graph out. It's going to make it very large going in the x direction. So this is a vertical. And what was the word they used here? Vertical stretch. This is a vertical stretch. And this is a vertical translation. That means it's going to move it down 1 unit. The graph of g of x is the graph of f of x equals x stretched vertically by a factor of 2 and then translated down 3 units. What is the function rule for g of x? So let's do part A here. So part A, it says it's stretched vertically by a factor of 2. So he starts off with x, so my g of x stretched vertically by a factor of 2 means it's going to be 2x. And then translate it down 3 units, it means minus 3. What transformations change the graph of x squared to the graph of this? Well, there's actually a couple here. First of all, if we're looking at part B here, now, we have a parentheses. Now, a parentheses moves the graph left or right, so, and what makes it 0, so you notice on here, what plus 4 is 0 on here, so negative 4, so this is going to move it to the left. Move my whole graph to the left 4 units. And then the minus 2 is going to be down 2 units. So that's what's going to happen on that graph. Okay, now let's look at another one. Combining transformations. The graph of gx is the graph of f of x equals 4x compressed vertically by the factor of 1/2 and then reflected in the y-axis. What is the function rule? Ooh, that was a tough one. Reflected, okay, first of it stretched vertically, if you think comparing not stretch, compressed vertically by a factor of 1/2. So my new function, I'm going to do this in a couple of steps. New function is going to be 1/2 of 4x, which is going to be equal to 2x. So there's my first one. And then it says reflected in the y-axis. Now the y-axis, remember, is the y-axis deals with a negative x, so therefore it's going to be plugging in negative x into this equation, 2 times a negative x, which is equal to a negative 2x. So my new function that's compressed by 1/2 and flipped is at negative 2x. Some of these will be very difficult for you, and that's okay, because we're going to have to practice these as we go. Vertical translations, notice the summary here. I want you to just look through it. I'll give you a second. Translations up or down, horizontal is left or right, stretched a in front, and reflect with a negative or negative. And that finishes off this section. So hopefully it's a good section. I'm guessing you're going to have some questions, which is okay. Make sure you bring them to me. If you could, bring them before class so I know what to expect. Thank you.